Hello everybody, welcome to a new Amaze. So this is the third episode of the Agentic Patterns from Scratch series. In previous videos, we have learned how to implement a reflection agent and also a tool agent. You have the links to the videos in the video description, by the way. Today we are going to focus on the planning pattern and we are going to implement a ReAct agent using the ReAct technique. Maybe you are familiar with the term ReAct, but more related with front-end development because of the front-end framework. Today we are going to talk about a different ReAct. This ReAct stands for Reason and Act, and it's based on a paper that I have shared with you on the Jupyter notebook on the introduction. It's based on a paper that tries to improve the planning or the reasoning capabilities of LLMs. As I was saying, I will leave you the link here, but I don't want to get into the paper here. So what I will do is to show you a simplified version of this ReAct agent by using this beautiful diagram. So this diagram showcases really well how the ReAct technique works under the hood. It's basically a loop that consists of three different components or three different steps: the action step, the observation step, and the thought step. The action step is basically running a tool. It's nothing more than that. The agent decides to use a tool and it runs the tool. Then the observation step is the step in which the LLM is going to make an observation about the output of the tool. Then we have the thought step, where the agent is going to reflect on the observation that is just made. And it's going to decide what to do next. Maybe it decides to call off the iteration process, so the agent finishes the loop and it returns a response to the user, this output in here. Or maybe it decides to use another action and continue the iteration. All right? So that's basically the technique or the loop, the logic that we are going to implement today. So now let's go into as always, into the Jupyter notebook. Here you have, as always, a short introduction about the planning pattern, what the ReAct technique is, also the link that I told you about before for the ReAct paper, and links to the previous lessons, because many of the things that we will do today are based on the previous lessons. So if you haven't watched the videos and you haven't checked the code, I recommend you to do it, because many of the things, even some utils that I'm going to import or how we are going to create the tools, is based on the previous video. So I recommend you to take a look. All right, so let's get into the relevant imports and the Groq client. As you know, this series is based on Groq models. We are not going to use any kind of framework, no LlamaIndex, no LangChain, no CrewAI, just Groq calls, Groq API calls. So in here, we are just going to import some typical Python libraries and also the Groq client. And we have here some utils. One of the utils is this tool decorator that we used in the previous video. Remember that this tool decorator is able to transform automatically a Python function into a tool, right? Into a tool object. And this extract tag content, which is something new I created for this video, is a very similar function that the only thing that it does is to, given a text input, it's going to retrieve the content within some XML tags. Maybe it's very abstract right now, but when you see it in action, it's going to be really clear. Oh, and by the way, I'm using this Llama 3.1 70 billion parameters. In the previous video, we were using Llama 3 70 billion fine-tuned for tool use. Today, I wanted to try another Groq model, so I decided to use this one, and the results are really, really cool. All right, so let's run this cell. And let's go into some of the tricky parts of the ReAct implementation, which is the system prompt. Okay, this is the system prompt. If you take a look, a quick glance, at first it will appear to you really similar to the tool system prompt that we implemented in the previous video, but it has some differences. For example, I'm telling the LLM to behave like, or to operate by running a loop with the following steps: thought, action, and observation, which, as you can imagine, is linked directly with this diagram. I'm telling the LLM to behave like this, to implement or to select the operations from these three operations: thought, action, and observation, which are the building blocks of the ReAct technique, as we explained previously. All right, so apart from that, you can see that everything is the same. We are telling the LLM to return the tool calls enclosed by these XML tags. Also, we are defining the available tools. This is something that we are going to parse, that we are going to complete when we have all the tools defined and the function signature generated. And now the example session. This is the most important part because it's the moment when we defined the ReAct tool, the ReAct loop, sorry. One thing that I want you to notice is that I'm using XML tags for every message. And why am I doing this? So I discovered that the LLMs are working much better when I input this kind of structured messages, and that's the reason why I chose to make everything this way. I mean, I could do something like question, semicolon, and thought, semicolon, things like that, but I discovered that it was not as accurate. I mean, it was difficult to parse the output when I was using this kind of a structure, and it worked much better like this. And I think it's even much clearer if you want to read it. I mean, at least for me, it's much more elegant, this solution. Okay, so let's get into the loop. So first of all, we are going to ask a question, and this question is going to be enclosed by the question XML tags. Then the LLM is going to think about this question. This is like an LLM internal thought, enclosed by the thought XML tags. I need to get the current weather in Madrid. Then the LLM is going to provide a tool call. It's going to select a tool from the available tools, and it's going to provide a way to run this tool, all the arguments necessary to run this tool. In this case, it's going to use the get current weather, and the arguments are going to be location Madrid and unit Celsius. All right, then the LLM is going to be called again with this message, an observation message. Remember that this is run, the observation was the step just after the action step. And this observation, which is as well enclosed by the observation XML tags, contains the output of the tool. In this case, temperature 25 and unit Celsius. Then it outputs a response enclosed again by its specific XML tags. The current temperature in Madrid is 25 degrees Celsius. Okay, so if the agent returns a message like this response message, it means that the loop has to be finished because it has a final response. Of course, in practice, this is not going to be the case because maybe after this observation, the LLM decides after the thought process to use another action and then think again about the output of the action and use another action. I mean, the loop could be extended by any iterations as needed. But the moment that the LLM returns this response message, then it indicates that the agent is going to stop the loop. All right? And finally, I've added some additional constraints. If the user asks you something unrelated to any of the tools above, answer freely, enclosing your answer with response tags. So this is basically because suppose that I ask the LLM what's his name or to write me a poem. In this case, I don't want the LLM to run a tool for that because that's not needed. I mean, it can default to its own weights to generate a response. It's not necessary for the LLM to access the outside world with any tool. So that's basically what this constraint is doing. All right, so let's run this cell. Now we have the ReAct system prompt in memory, and let's start the example step by step. So we are going to start by defining the tools. In this case, I chose to create 3 tools. As you will see, they are very basic tools. We have the sum 2 elements tool, which accepts 2 parameters, A and B, 2 integers, and as you can imagine, it sums the two elements. Then we have the multiply 2 elements, which, as you can imagine as well, it multiplies A and B, so nothing fancy here. And finally, the compute log, which, surprise, surprise, it also it's basically the logarithm of the input, this x, which is going to be an integer. All right. And remember one thing, that we are going to define the tools by using the tool decorator, which we defined on the previous video. And what it does is to transform the Python function into a tool object. All right. Finally, we are going to define this dictionary that relates the tool name with the tool object. And we are going to, verify that everything works by using these sum2 elements and accessing 2 of the primary attributes of the tool. So if we run this cell, you will see that we have the tool name, sum2 elements, and also the tool signature, which contains the name. It also contains the description with the docstring, and this is the most important argument, the parameters, which contains the properties A of type int and B of type int as well. So everything seems to be working fine. Now let's get into the system prompt again, because we need to add the tool signature, the signature for the 3 tools that we have just implemented, into the React system prompt. All right, so first of all, I'm going to create this variable by concatenating in this scrappy expression the 3 function signatures. Let's check it, but as you can see, we have the signature for the sum2 elements tool, the signature for the multiply two elements tool, and the signature for the compute log tool. All right, and now let's simply add this tool signature into the system prompt, and let's print the system prompt to see that everything is worked fine. And as you can see in the tools XML tags, we can see enclosed the 3 function signatures. So everything seems to be working smoothly until this point. Now we have everything ready to start implementing the React loop. And I have divided this loop in different steps to make it easier for understanding. So let's begin with the first step. The first step involves the user question. In this case, I wanted to ask the ReactAgent this question. I want to calculate the sum of 1, 2, 3, 4 and 5, 6, 7, 8 and multiply the result by 5. Then I want to take the logarithm of this result. Okay, this is my question. So the first thing that we are going to do is to generate or create this chat history using the system prompt. That's the first message, the first prompt that we are going to add into the chat history. And then the user prompt. And remember that we are going to use all the time these tags, these XML tags. In this case, since it's the user question, we are going to use the question tag. All right, so let's create the chat history and let's run the first completion. All right, so take a look here. We have 2 messages. The first one is a thought message. I need to calculate the sum of 2 numbers, then multiply the result by a specific number, and finally calculate the logarithm of the result. And then we have a tool call, which is going to call for the sum2 elements tool, which seems okay. And then it's going to use this argument. So A is going to have a value of 1, 2, 3, 4, and V of 5, 6, 7, 8. So everything seems to be working fine. The LLM has chosen to use the sum2 elements first, and it makes sense because if you look at my user question, I'm asking first of all to sum 1, 2, 3, 4 and 5, 6, 7, 8. So it makes sense to for the LLM to have chosen this action as the first one. Now let's add this output to the chat history as a system role type. And now let's get into the step 2. So in this second step, we are going to use the extract tag content that I mentioned previously. This extract tag content is going to take all the text enclosed by the tool call XML tags. So in this case, it's going to be basically this. All right, it's going to take this dictionary, this string dictionary. All right, and as you can see, this extract tag content, is not going to return the plain string. It's going to return a data class, so we need to access the content attribute. All right, and then inside the content attribute, we need to access the first index because it's going to provide a list, and we need to access the first element in this case. All right, so as we can see, the dictionary seems pretty good, seems fine. And now we just need to run the tool. So we are going to access the tool from the dictionary of available tools, and we are going to run this tool with the arguments, with these arguments. All right. And now we are going to make this assertion because I wanted to make sure that the tool result it's the same, and it needs to be exactly the same as the mathematical result that we are sure of. So yeah, this assertion basically computes that, and since we are not getting any assertion error, it means that everything is working fine. And now let's add this content into the chat history. In this case, the role type is user, and remember that we need to use the observation XML tag to add this observation into the agent, because remember that just after we execute an action, the ReAct technique is going to perform an observation on the tool output. And that's exactly what we are doing with this XML tag here. So let's add the chat history, and let's move into step 3. So now let's run this completion, and let's see what the LLM has to say. And it's going to think again about the observation that it just made. So the thought says the following: I have the result of the sum. Now I need to multiply it by 5. All right. So it's sensible. It makes absolute sense. And the tool call that it's going to use is the multiply two elements. So perfect. And the arguments are going to be 6, 9, 1, 2 as A and 5 as B. So it makes sense. It makes absolute sense. Let's add the output into the chat history with a role type of assistant. And let's move into step 4. I'm not going to get into the details of these cells because it's basically the same as we did here, okay, but for another tool. So just run this, check the tool result. This is basically the multiplication of 6, 9, 1, 2, and 5. And now let's corroborate that everything is working fine, which it does. And let's add the result into the chat history. And remember, we need to add this result as an observation XML tag. All right. All right, so let's get into step 5. Let's run the completion and let's see what the LLM has to say again. And in this case, it says that it has the result of the multiplication, but now he needs to calculate its logarithm. So perfect sense again. The tool call in this case is going to be compute log, and the arguments 34560, which is the result of the sum plus the multiplication. All right, so let's append this assistant message into the chat history, and let's get into step 6, where we are going to run the last tool of this loop. This is the logarithm after we compute the logarithm of 34560, and let's make the typical assertion to check that the mathematical computation is the same as the tool result. Now let's add the user message into the chat history. Remember, once again, I want to remind you of this over and over. We need to put the observation XML tags for everything to work smoothly and properly. Finally, we are getting into the step 7, which is going to be the final one. And if we run this, you will see a beautiful XML tag saying response, which means that the agent has decided that the loop is over. And now we can read the message. The result of the calculation is a logarithm of approximately 10.45, which is exactly the result that we got here after applying the tool result. So we have managed to make this React logic work, but as you can imagine, this is not the way to implement it like the good way, because we are not going to implement each one of the iterations from scratch and manually. We need a way to implement everything automatically. And that's exactly what I'm going to show you right now in VSCode. And then we are going to see all of that code in action in the next section. But first, let me show you how the React agent is implemented in the code base. So let's get into VSCode. Okay, so here we are in VSCode. So as we did in previous videos, you just need to go into the source folder, Agentic Patterns folder, and inside just click the folder related with the topic of the video. So today we are learning about the planning pattern. So simply get into the planning pattern folder, and inside click the React agent. And if you scroll down in this module, you will see some familiar things, like for example, this React system prompt. This React system prompt is basically the same that we used in the Jupyter notebook. It's exactly the same. I just copy and pasted this React system prompt to the Jupyter notebook, so there are no mysteries here. If you keep scrolling down, you will see the React agent, the proper implementation, and this is where you will see some differences with the code that we implemented in the notebook. So first of all, as attributes, we are defining the Groq client, also the model that by default, remember that we were using Llama 3.1 70 billion, a list of tools, and the tool stick that we defined also in the Jupyter notebook, but in here it's going to be an attribute, a class attribute. All right. Then we are defining as method this addTools signature. That remember that we did something very similar in the Jupyter notebook, but in this case, it's not as scrappy as the implementation that we did in the notebook. This is much more subtle, much more efficient. And then we go into the process tool calls. This is some of the core logic of both this agent and the tool agent. And let me read to you the Docker, the doc string, because it provides a really good explanation of what this method does. So it processes each tool call, it validates arguments, it executes the tools, and collects the results. And as you can see, it's not that different from what we did in the notebook, but this is like a proper implementation. And one of the key differences is this validates arguments functionality. Because in this case, we are not just running the tool and getting the results. In this case, we are also validating the input to that tool. Because we don't want to end in a scenario where a tool is expecting an integer and we are inputting a string, for example. That's something that might happen, and we want to contemplate these type of situations. All right. So, but that's basically what this method is going to do. It's just processing its tool, running its tool, and collecting all the results and returning the results with this observations variable, which, as you might imagine, it's linked to the diagram that I showed you at the beginning of the video. All right, and now we have the last method, the run method. This is a common method on the 3 agents that we have implemented so far: the reflection agent, the tool agent, and now the planning agent, the React agent, are implementing this run method. And the difference between this React agent and the previous tool agent is that in this case, we are running another loop inside the run function. And this loop, as you might imagine, is the React loop. Okay, so let's go into the different steps of this loop. But first of all, we are going to run the completion. Then we are going to check if this completion contains a response XML tag. In that case, we are going to cancel the loop. We are going to simply return the response. Because remember that the response XML tag means that the agent has decided that that's the end of the loop. It has discovered a response. It has a valuable response for us. So the loop can be canceled. Okay, if we continue, you will see this thought and this tool calls variable. The thought variable is basically the thought content, all the content enclosed by the thought tags, and the tool calls is basically the same, but for the tool call. That's exactly what we did on the Jupyter notebook. All right. So after this, we update the chat history with the completion using the system role, and then we print some beautiful logs with colorama using magenta in this case, and we are printing the thought. You will see this in action in a few minutes later when we run this in the Jupyter notebook, but that's basically it. I mean, we are just printing the thought. And then we are going to check if there are some tool calls in the completion. If that's the case, we are going to run the process tool calls. That is the method that I explained to you before, where we are going to run all the different tool calls that we need. And we store the result in this observations variable, and we print the results with another color, in this case blue, and these are basically the observations, if you remember the diagram, the ReAct diagram. All right, and finally we are going to update the chat history using user role type, and we are updating with the observations. That's the message that we are going to add into the chat history list. Okay, and that's it. Then we start again the loop and we keep iterating. So there are two things that might happen that return a value to the user. The first one is that the agent finds a response XML tag, as we already mentioned. The other one is that we get into the max rounds, into these max rounds that I defined at the beginning of the run method, that defines the maximum rounds for the ReAct logic to iterate. And if we go beyond these max rounds, it means that the agent hasn't found any response tag on the completions. So what we are going to do is simply to return the completion of the current chat history. All right, so that's basically the logic. As you can see, it's really simple. I mean, it's just a simple loop with I don't know, 20 lines of code. But this is basically a version of the ReAct technique. Okay, so now let me show you this in action in the Jupyter notebook with all the colors and colorama, etc. I think you're going to like it. Okay, so the first thing that we are going to do is to import the ReactAgent, and then we are going to instantiate this ReactAgent using the 3 tools. All right. And now let's run. I just copy and pasted the user message that I use here, that I created here. So let's run this and see what happens. Okay, everything seems to be going really smoothly. All right, this is really cool. So as you can see, the colors improve a lot, the readability. So we have a first thought. I need to first calculate the sum of 1, 2, 3, 4 and 5, 6, 7, 8. Then multiply the result by 5 and finally compute the logarithm of the result. Then we are going to use these tools. This is basically the action. Sum 2 elements. This is the tool called dict. Sum 2 elements and 1, 2, 3, 4, 5, 6, 7, 8. And the tool result is this one. And the observations, which is 6, 9, 1, 2. Then there's an additional thought. Now I need to multiply the result by 5. And we are using the tool multiply 2 elements. The tool called dig, multiply 2 elements, arguments, 6, 9, 1, 2, the result of the previous iteration, and 5, which is the multiplier. And the tool result is 3, 4, 5, 6, 0. All right, so the observation is basically that result. And a last thought, now I need to compute the logarithm of this result. So the LLM chooses to use, in this case, the compute log action, compute log tool, and it computes the log by using 3, 4, 5, 6, 0. That's it, the tool result of the previous iteration. And finally, we get this result, 10.45, and the observations are basically that result. So the final answer is that the sum of 1, 2, 3, 4 and 5, 6, 7, 8 is 6, 9, 1, 2. Multiplying this result by 5 gives 3, 4, 5, 6, 0, and the logarithm of the result is 10.45. And as we can see, if we scroll up, that's exactly what we achieved, the result that we got when we were running everything step by step. I hope that you are excited because you have successfully implemented the ReAct technique, which is one of the most known techniques for reasoning, for improving the reasoning capabilities of LLMs. In fact, if you go to LlamaIndex, if you go to CrewAI or to LangChain, you will see that the core agents are implementing this technique. So congratulations, because you have learned how to implement a very, very important technique. Okay, and this is everything for today. I'm currently working on the next and last video of this series about the multi-agent pattern, but until that moment, nothing much to add. I mean, subscribe if you like the content, click the like button if you have enjoyed this video, and I guess I'll see you in the next video.